Welcome back, everybody. So this is the second part. It's just a brief overview of the process. In this case, we use silicone rubber to actually make a mold. So you see the process in the most simple way, just to have an overview of the entire thing. Um, the objective is to replicate a simple object that I 3D printed with some defects. So you see also how the defects from the master, the object that you copy, will be transferred through the mold to the replicas that you make, and therefore the importance of making things properly. So the object is very simple. It's a 3D model of a bone that I downloaded from Thingiverse, an online platform with very few resources for medical applications, but very simple to use. So we started from that. I made a small structures with a couple of toothpicks and hot glue to hold it in places, and I will show you the entire process. Okay, so this is the object, very simple. As I said, two toothpicks to hold it in place. On the side, even if it's not easy to see, you can notice some parts that were not perfectly printed. Now, those defects will definitely appear in the mold. Okay, so we see also the final result on the plaster that will copy the object. Now, our container is going to be a very simple plastic tube. This goes inside, and I want to be sure that there's enough space in every direction to allow a decent wall thickness. When it's properly placed, I can glue it a bit. Just to be sure that it's not going to move. And eventually decide if it's better probably to keep it balanced, so halfway. Okay. Now, while the hot glue cools down, we can start to work on the resin. What we need is a scale, a tiny container to mix the resin. Then I have the catalyzer and the box of the resin. Now, checking the label of the resin, it's written that it's a 20 Shorey grade with a pot life of 15 minutes and 2 hours before being able to remove it from the mold. So this is more or less what we are going to work with. Last, of course, very important thing is the proportion, 5% in weight. So we turn on the scale for the resin. So let's see. We have 200 grams of resin. Now, after this, 200 grams means 10 grams of catalyzer. We pour the catalyzer. A bit more. Okay, perfect. Now, from now on, respecting the pot life of the rubber, we have 15 minutes to mix, pour, and do the entire process. So you see that the catalyzer has a completely different color. That helps us to figure out when the resin is properly mixed. Now, the container I'm using, of course, is just a piece of a plastic bottle. The problem with containers like this are all the features on the surface. So it's not a smooth surface, and there is the risk that some uncatalyzed rubber stays in these areas. Even the bottom has the typical shape of a plastic bottle, definitely not the best. Now, we were saying before, when you mix the resin, you should be gentle, not whip it. So I'm trying to don't incorporate air in the process, but mixing from bottom to up to allow new resin to get in contact with the catalyzer and the catalyzer to get embed in the resin. Now this process can take a few minutes, so I will try to speed up a bit, knowing that going too fast means that there's the risk to embed too much air in the material. You see that the center is still very clear. That means that is far from being homogeneous. I can go on mixing it a bit more. Okay, almost done. The color became much more homogeneous, but you can see some bubbles getting up. Unfortunately, as we said, it's very hard to completely avoid them or remove them. So we just have to try to pour it properly to take them out. Now you see that with a bit of time, bubbles are getting to the top of the surface. So some of these are actually exploding already. That's a very good sign. Now, something important, when you pour the resin in the mold, you try to make a very thin border and let it fall from as high as you can. You see some times something a bit thicker. Those are actually the border of the bubbles, so it's quite possible that falling down from such a high distance, the bubbles will explode. This also allows the level of the resin to grow slowly, the level of the silicone, sorry, to grow slowly, and because of that, push out the air from the surface. Now, in this specific case, the object is quite simple, so there's no particular risk of making big bubbles, but if you have complex surfaces, that's much more common. Now, it took us less than 15 minutes, so the pot life of the resin, so it seems to be pretty good. That also means that we have some times to let the air flow to the surface. Okay. Now, just to show you, even if it's in this case probably not needed, sometimes you just pour back all the resin to be sure that you create a sort of layer, very thin layer on top of the object with very few bubbles on the most critical part, that is definitely the surface of the object. Now, The hot glue left some tiny pieces. At this point, the surface should be already properly covered, and I can pull it back the same way I did it before. Now, with a short pot life, this is quite risky, and 15 minutes, it is quite short, to be honest. But it was to show you the entire process. Okay, it's not easy to show it on camera, but you can definitely see the bubble exploding, popping more than exploding, when they get in contact with the surface. In particular, going through such a thin okay, almost done. Let's say it should work quite well. Okay, now the amount of silicone was pretty good. There's still a bit left inside. That's actually a good thing, because if you want to check if your mold is ready, the easier way is actually to check what's left in your tiny container. I usually keep the sticks inside as well. Personal suggestion, you see I made a tiny drop falling on the table. Don't try to clean it up. Just leave it there. After it catalyzed, it becomes much easier to remove everything. So right now you need solvents and it's not a clean process. If you wait and you let it catalyze, you have really no problem. Okay, so that's it for the molding. We need to wait a couple of hours now and then pour the remove the master and pour the material inside to make the copy. In the while, I can show you something about the different kind of silicones. So this is a sample. These are two samples I got from two different kind of silicone. And you can see that one is much more stiff than the other. So I'm basically holding them the same way. And you can see one flecting, bending more than the other one. Now this is a 20 shore and this is a 30 shore. But the interesting thing is actually, these are two old molds that I can definitely sacrifice, is the resistance to the tear strength, as we were saying. So this already broke a bit, and but if you try to pull it apart and rip it, it opposes quite a bit of, you know, strength to the process. It's not an easy thing to do. While in this case, it's really easy. You see the corner, it really moves fast, the crack. Now, this is a low tear strength, and this is a medium one, not even a high one. But the feeling is really, really noticeable. In particular, if you try to cut it, so cut this is really like going through without any problems, because cutting is strongly related to the capability of the rubber to oppose to this process. While cutting through this material, it's still possible, but you perceive much more friction, much more bending. You feel the bending of the resin before actually let the blade go through. So even in the center, when you cut it, and this cut, I'm actually stretching it and it's not breaking too much. While if I do the same thing here, besides being much more easy, as soon as I bend it, it really goes through. So it's important to choose your tear strength of the material based on the application you want to have, and eventually test different samples. Last important thing you notice inside both of these rubbers, let's see if I can focus on the camera. You notice inside both tiny bubbles. Now the problem is not having bubbles in itself, is where the bubbles ends. So in this case, it's inside the material, is not a big deal. But as soon as you have something similar on the border of the object, let me see, these molds are actually pretty good. So you don't have bubbles on the surface. But in average, you could find maybe on tiny details, on the texture here, if there's a bubble that gets trapped, well, probably very tiny one. So in this case, not a big deal. But if you see the walls, here there's no wall. That means that in that case, there was a bubble. So tiny defects here as well. In this case, is really, really a minor problem. But if you have big gaps, then they will appear on your molds. So that's it for the first part. We have to let the silicon cure properly. As I said, it's going to take a couple of hours. So in a couple of hours, we can demold it, see the process, pour something, wait another 30 minutes for the plaster that will pour in to cure, and see the final result. Okay, so we waited a couple of hours more or less. Now the mold seems to be ready. We can try to demold it and take away the main part and cast a replica of the original object. So we can remove the pieces. Now at this point, I don't need the bottom part anymore. Ideally, we want to keep the cylinder, but it's not going to be easy to take out the piece in and out without cutting it. So probably we have to cut through. Okay. Now, perfect. This is our mold. Now, ideally, with a very soft kind of rubber, could have just, pulled it out. That's not feasible in this case. So what you do usually is to cut, but with an irregular shape. This makes it easier to align the pieces together. So okay. After opening it, I can pull out the thicker part of the bone, and this would be my mold. Now, the border cut in this way helps a lot to align back the thing and don't see the cut. And of course, I can put this back inside here, hold it, with paper tape or rubber bands, and that would be already, a very good solid um, structure for the mold. So let's try to fix this, mix the plaster, put the plaster, and create a replica of the original object. Okay, so with a bit of tape, I can go around the cylinder. What's important is that it's tight and aligned, of course. Okay, this should be definitely enough to keep things in place. Now about the material and the plaster. This is simple plaster. It's good to do the tests because it's enough to mix it with a bit of water. Maybe I can add a bit of plaster. The consistency seems good. At this point, so vibrating the mold a bit, it helps to actually be sure that the plaster got to the end. You see some bubbles popping up. That's a good sign. Also squeezing it a bit. Okay, seems good. I can remove the excess. Just to be sure it's going to be easier later to get a nice finishing on the back. Okay, so now it's just a matter of time. We still have to wait a bit for the plaster to cure. Half an hour more or less, and we can probably be able to unmold it. So second attempt to actually cast the material. I waited way longer than before. Plaster can take a while. It also depends on the kind of plaster you use. So better safe than sorry. It's good to give it a bit more time. Now the mold is here. We can open it. Just remove the tape as before. Let's see where the cut is. Okay. Now a bit of plaster seems to cut through the crack. So let's see if we can demold this. Okay. Good, much better. Now there is a bit of flashing on the borders of the cut, but being pretty regular is not that noticeable. But there are a bunch of details that it's good to actually check. So let's see if we can focus on this part. Okay, so it seems the light is not good enough to actually show you what I meant. So the defects we had on the 3D printed part has been basically perfectly copied on the object as well. It's pretty normal to have bubbles in plaster, but of course mixing it and pouring it inside didn't help. You can see the layers of the printer, in particular when it gets almost flat. And this is basically the replica. And you can see how precise it is in replicating the details of the object. So it's quite amazing. So that's it. That was the test that we made. Making a mold like this is very simple. It's not the most effective way. You notice how difficult it was to take this out. Very often you open it in both sides and you just use two parts basically. In this kind of mold, unless you make very specific features, there's no way to let the air out from complex shapes. So it's really only for very basic things. But you know, the process is hopefully a bit more clear, and we have the first replica of our bone. So see you at the lesson on Friday, and we'll get into more practical details. Goodbye.